Welcome back to College Algebra. Today we're going to be looking at section 5.4, which is dividing polynomials. I'm excited to get started today. This is a fun topic because it takes something from a long time ago, which is division and long division of numbers, and translates it into what we're doing today, which is working with polynomials. So let's jump right in. Along that vein, I think that the scripture verse for the day comes from 1 Corinthians 13. It says, "When I was a child, I spoke like a child, I thought like a child, I reasoned like a child, but when I became a man, I gave up childish ways." And this is kind of speaking in a chapter that's about love and about Jesus and the way that he transforms the life. Yeah, that's about our spiritual formation and how we as Christians grow closer to God and spiritually form as we develop. But he's reflecting on when he was a child, the things he did were very childish. And when he grew up, he put away those childish things. And today we're going to reflect on when I was a child, I divided numbers in like the 4th grade. And today we're going to put aside those childish things and divide some really long polynomials. So let's jump right in and get started. The division algorithm is an algorithm from a long time ago. You have done division before. It may be hard to remember, but here's kind of what you might have seen before. 2 goes into 17, or maybe I'll do a bigger number, 43. And you would say, okay, 2 times what equals 4? And you'd put a 2 on the top. And then you'd multiply those two numbers and write it right here, and then you'd subtract them. 0, drop it down, 3. 2 goes into 3 how many times? 1. And you do 1 times 2 is 2, subtract them, and you'd get a remainder of 1. That's all we're doing today, just with polynomials. So I'll show you this step by step, and we'll work through it together. We are going to divide 6. We are going to divide 16x cubed minus 12x squared plus 20x minus 3 by 4x plus 5. And if you remember back to when we did polynomial operations, back in chapter 3, when we were talking about functions, we kind of skipped over division. We never really did, how do you divide two polynomials? That's because we have a whole section on it today. Okay, so the first thing we're going to ask ourselves, we're going to look at this first term and say, how many times does 4x go into 16x cubed? And so you might say, well, it's definitely got a 4 in it, because 4 times 4 is 16, and it probably needs to have an x squared, because 4x squared times 4x would be 16x cubed. And then off to the side here, I'm going to write 4x squared times 4x plus 5. And I'm going to do that distributive property. 16x cubed plus 20x squared. And then I'm going to write that distributed term underneath. And then what I'm going to do, and this is the most important step that's easy to forget, is I'm going to subtract the whole thing, which means I need to subtract every single term. Both terms need to get subtracted. And so 16x minus 16x is going to give you your 0 and all cancel out. But then you're going to subtract this term too. And 12x squared, negative 12x squared minus 20x is negative 32x squared. That's the most important step to not forget, is that you have to subtract both sides. And then we'll drop down everything that's left, and we'll do it again. We can change colors. All right, now we're going to ask the same question. How many times does 4x go into negative 32x squared? We'll say, okay, well, 4 times 8. So we're going to say negative 8 to make it a negative. And then we're going to need at least 1x. And so off to the side, we're going to distributive property this, and we're going to say negative 8x times 4x plus 5. And if we do the distributive property again, we get negative 32x squared minus 40. And we write that underneath. And then we need to do the most important step, which is to subtract the whole side, which will change all of the signs to positive. And we cancel out the first term. and we're left with 60. Oh, I dropped my x. And we're left with 60x drop down the -3, and we got a -3 there. Yep. Okay. And then we're going to look at the next term, and we're going to do it one last time. Change colors one more time. And we're going to say, how many times does 4x go into 60x? That's a little bit harder of one. We'll say 4 times 15. Positive 15 is a 60x, because 15 times 2 is 30. Double it is 60. And we don't need any x's because it's already accounted for. And so we'll say 15 times 4x plus 5 equals 60x plus 75. 5 times 15 is 75. All right, and then we'll write that underneath, 60x plus 75, and then subtract both terms. Don't forget that most important step of subtracting the whole side so that it cancels out. And so -3 minus 75 is -78, and there's my remainder. And so what we're going to do with that remainder is we're going to come and write it at the top. So we're going to write plus -78 divided by my divisor, 4x plus 5. And so my final answer is up there at the top with the remainder included, written as a fraction added to the whole thing. 4x squared minus 8x plus 15 minus 78 over 4x plus 5. All right, and that's long division. That's the only example I have on long division, so if you need to rewind it or watch it again or slow down and practice it, you're more than welcome to do that. I would encourage you to and practice some of these at home because it's not obvious on the first go around exactly where every number came from and how we worked it. All right, let's move on to something that's a little bit easier called synthetic division. And synthetic division is just a really specific case of long division where you have a perfect factor right here. And what I want to think about is if that is your factor, then there's associated a 0 that goes with that factor, or an x-intercept that goes with that factor. And if you set it equal to 0 and solve it, you would get x equals -7. And that's your 0 that's associated with that factor. So when your division takes the form of a factor, you can use this special process, which says I'm going to put the -7 inside of a backwards L. Notice it's not the +7 from the factor. It's the 0 that we're checking. It's almost like a 0 check. And then what I'm going to do is I'm going to take all of the coefficients and I'm going to look and be careful that they skipped some coefficients. So right here you'll notice there's a term missing. Technically in this equation there's a 0x squared that's missing. If you miss that, then you'll get a wrong solution or you'll get a wrong quotient. And so you really need to watch and make sure you have every single degree accounted for. So you have x to the 4th, x to the 3, x to the 2, x to the 1, x to the 0. Now we can write, we've included that missing coefficient. We're going to write just the coefficients. So 3, and then 18, and then 0, and then -3, and then 40. So it looks kind of weird right now, but I promise it's really useful. And then we're going to drop down the first coefficient. So we're going to drop down the first coefficient, so it's just a 3. And now's where the process happens. We're going to always multiply along this blue arrow, and then we're going to add along this red arrow. And we're just going to do it over and over again. And so 3 times -7 is -21. and then we add these two numbers. So we get a negative 3. And negative 3 times negative 7 is a positive 21. This one just got multiplied. We just added it to the multiplication. And then we add those two numbers, which gives us 21. 21 times 7 is negative 147. And if you add those two numbers up, you get negative 150. And negative 150 times 7, you can definitely use a calculator for this, is positive 1050 or 1050. And if you add those two numbers up, you get 1090, and your last number in the sequence is again your remainder. And so how we're going to write our quotient is I like to start on the far end and write my remainder first. So I'm going to write 1090 over, again, we're going to use our divisor, which was x plus 7, plus, and then we're going to go grab our first term, and that's our constant. So we get 150 with its negative sign, and then we write our next term with the first x as its solution. And so we're going to like backfill here in green x, x squared, and x cubed for our final answer. And so we're going to go 21x plus negative 3x squared, 3x cubed. And what I did is I just took that line, backfilled green x's, starting at the constant though, starting with the constant, not starting with the first x. And anytime you're missing the plus sign, you can add the plus sign in for yourself. But if it has a negative sign, you leave it alone and you leave that negative sign there. And this got plus 1090 over x plus 7. And there's your quotient. All right. So we're going to use these two rules and pick which one works best to find the area of a rectangle. So if you remember the area of a rectangle, the formula is length times width. And they give us in the problem the area of a rectangle is 3x3 plus 14x2 minus 23x plus 6 equals, I'm going to put parentheses around it to be careful. They do not give us the length, but they do give us the width. They say the width is equal to, so we don't know the length, but we do know the width is equal to x plus 6. Right there in the problem. And so what we're going to do is we're going to say L is equal to, and we're going to divide both sides by that x plus 6. We're going to get this long term divided by x plus 6. We just divided that parentheses set from both sides. And that's our division problem that we're going to do. And so because this divisor looks like a factor, we're allowed to backwards L and say negative 6, remembering that the factor was x plus 6, so the associated 0 is x equals negative 6. This is the 0 of the term, and this is the factor. And then we're going to fill in from the top all of the coefficients that we see. So 3, 14, negative 23, and 6. And notice we don't see that we are missing any degrees or any exponents. It goes from 3 to 2 to an invisible 1 right here to your constant. So I can just write 3, 14, negative 23, and 6. I drop down my 3, and then I just use that same algorithm of multiplication and addition. And so 3 times negative 6 is negative 18. Add those two up, you get negative 4. Multiply negative 4 by negative 6. We're going this way and then this way every time. Multiply negative 4 by negative 6, and you get positive 24. 24 plus negative 23 is 1. 1 times negative 6 is negative 6. And 6 minus 6 is 0. Boom. And there is our remainder. We don't have one. There is no remainder. And so we can go in and backfill and say this is our constant. Remember, don't start with the x, start with your constant. Fill in an x and a plus sign. Fill in an x squared and no plus sign because there's already a minus sign there. And so what was the formula for your width? It was 3x squared minus 4x plus 1. All right. So that's two different ways. Oh, that was our length. We were solving for, look up here. We were solving for length the whole time. We already knew width. All right, so that's two different ways that you can divide. You can long divide and you can synthetic divide. Synthetic division only happens when the factor is a nice, neat factor that results in an easy zero that you can find. When you have it of the form x minus k, this is broken up right here, but when you have it of the form x minus k is when you can synthetic divide. All right, we're going to look at the implications of this division next week, or in the next video, where we talk about the zeros and how you can find zeros quickly. But for now, those two things are today's two things: long division and synthetic division. I'll see you next time. Thanks for watching.